Hey everybody, this is Larry. This is me going Q3 of the biweekly contest 125. Count pairs of connectable servers in rated tree network. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is not actually that hard, to be honest. I feel a little bit bad about this because I spent 18 minutes on this because I misread this problem, to be honest. I was trying to prove all sorts of stuff because I misread this problem. And you could kind of see the live portions and you could see it. But it's actually not so bad, so don't worry about it. It's not that intimidating. But the... yeah, I don't know how... I just misread it, that's all. But the way that I would think about this problem... So I think the way that I would think about attacking this problem is that, okay, you have a tree, it is rated, but let's start with, or this is a n-ary tree, right? It's not a binary tree. It can go many each way. It could be a starry tree, kind of like example 2. I'm trying to highlight it, but it could even be more starry like that, right? But yeah, so the idea, or the, I guess it's not the hard part, but the first thing you have to observe is that n is equal to 1,000. Because n is equal to 1,000, it gives you a lot of n square solutions that will run fast enough because n square is just running a depth first search from each, or a traversal from each node as the rooted node. So then that makes it pretty much straightforward because after that, then you just have to count all these conditions, right? And basically, the way the idea about that is that in a way it's kind of like dynamic programming, but not really. I think you could kind of say it that way, but I'm going to bring up some drawings to kind of illustrate to you. But basically the idea, like I said, is just going to be brute force in a way, or exhaustively iterate every node. So let's say we have this thing, right? So this is the thing, and basically the idea here is that, okay, so we brute force every node. So for example, we may start at say 0. I guess this is 0, and then basically we just do a search on here and then this other direction, right? And here is just about counting it in a very it's just counting it in a very specific way, because basically if let's just say for purpose signal speed is 1, then now you count how many nodes that have signal speed is 1 on this side. So then now, and then you count the number of things that are on the other side, right? And of course, and then you can multiply them together, right? So that seems pretty straightforward. If you have a binary tree, that is relatively, because then now everything to the left and everything to the right of this, they kind of connect through this current node 0, right? So okay, but so that's fine. But let's just say we have a star tree like this one, right? Then what happens? I mean, it's the same idea. You go through each branch, right? But then the problem is, if you don't do it intelligently in a smart way, you may just do like, okay, well, let's just say maybe there's 3 nodes here. I'm just writing random numbers. 3 nodes here, 5 nodes here, 10 nodes here, and then you may go, okay, well, first we went 3, and then here you have 3 nodes here, so then 3 times 3 is going to be 9, and yeah, and then you go to this 5, and then 5 times 3 is 15, 5 times 3 is 15, and then you have 10 times 3 is 30, 10 times 3 is 30, 10 times 5 is 50, and then you sum it all together, right? And the reason, and just to be clear, maybe I didn't make it explicit, the reason why this is, say, 50, and 50 is just 10 times 5, is because you have 10 nodes on the left, 5 nodes on the right, and they go through node 3, right? And of course, if you do it this way, in the way that I showed you, it is going to be n squared, because there's just a lot of nodes, and you have a tree node that would be timeout, because now you have n squared per node, so that makes it n cubed in total, and n cubed is definitely too slow. So how do you solve this? How do you resolve this? Well, it turns out all you have to resolve this is kind of, like I said, is just dynamic programming, right? So instead of saying, okay, this is 10 times 3, 10 times 3, 10 times 5, and then sum it up, what you actually do is just say, okay, well, 3 plus 5. Let me change the colors real quick so I could draw on top of it without being confusing. So you have 3 plus 5, that's going to be 11, right? So then now what you're saying is you have 10 on this node and you have 11 on the other side that you've seen before. So that's 110. And that's basically the idea behind this. It's kind of a little bit from that logic. My code is very weird because to be honest, I did it, like I said, if you watch the live portion of it, I try to solve a different problem. So it's structured a little bit toward that other weird problem. And I solved it and I had to prove that fast enough. That's basically why. But that's why I had to kind of, yeah. But that's why the structure is a little bit weird, but hopefully at least it's, it'll show you enough that you can rewrite your own. So first, we have n. We convert the edge to an adjacency list. And then here, as I told you, we just kind of brute force saying, okay, going through I and, going through the ith node. Well, another way to think about it is I is the root. So then now you have all these branches. And then here is the calculation. I actually used an inner function for the recursion, but basically, and I kind of did this in a weird way because, I don't know, I just wasn't able to do the math. I was rushing a little bit and I wasn't able to do the math quite correctly. And I did this weird thing with R is equal to 0. As a bonus exercise, I'll actually, we'll rewrite this to be cleaner afterwards. But basically I get all the possible answers on all the branches. This is basically saying, given node x is the root, this contains all the branches. And then now we did what we were saying about the dynamic programming. But with current, we sum up all the previous ones, and then we kind of branch out the current x and then all the previous ones, even though this is current. And then you kind of sum it up and you return, and that is the answer. And like I said, this is going to be n squared because basically each node can be rooted once. And for each root, we just do a traversal of the tree, a depth first search of the tree, which is, of course, O of n. So this is going to be n squared in total. So this is pretty ugly. Like I said, after I solved the wrong problem, I tried rewriting it, and this is what I got. But if I wanted to stay clean, this is how I would write it, maybe. Let's kind of optimize this a little bit in terms of code. Right? So then now we can at least right? And so that's one optimization, right? That you can say. Or at least like code, I wouldn't say an optimization, but it's just like a cleaning the code, refactoring, if you will. So you get to see a live refactor. I'm just checking that this answer is correct still. I'll submit it though, it doesn't matter. It's more responsive right now. Okay, so it's still good. So then now we can do the second optimization, which means that we don't need this anymore. We can say x is 0 to this. And then, right, basically, yeah. Oops. Ooh, wrong answer. Huh. You see x. That's weird. What did I do wrong? Okay, so this is right. And then, that's wild. Oh, because I reused this x. This is terrible, actually. I forgot that this is how I called the root. And that's why this is like all kind of funky. Okay, fine. Yeah, because then it's, oh wow, that is such a subtle mistake. But I'm not having a good day clearly because you can see that I'm making silly mistakes everywhere. But I don't know. My excuse is that I just woke up, so I don't do same mistake. I don't do. I need to wake up a little bit earlier and actually be awakened for this, right? But yeah. So that's basically the cleaner version that you can fit on one page apparently. So yeah, you just count up all the nodes in which, and this is just this axiom, right? The distance between C is divided over by and the sharing of edges is because there's a tree they have to go through this node, so that's why it's rooted there. Pretty not that bad. I think this part is the kind of one observation. The other is that n is equal to 1,000, so you could do a brute force kind of thing. But yeah, that's what I like. I said n squared time over n space. That's what I have for this one. Let me know what you think, and you could watch me solve it live in the contest now. Let's take a look. That's good. You have a tree. Away edges. Yeah. What is this? A 5-pointer? C to B. Okay. I mean, it's a tree, so that's fine. Is this union fine? No, I don't know. Oh, yep. I thought you have to return the answer. This is huge. Well, this is actually pretty big as well. Usually I'm struggling with this, but okay, fine. Alright, just construct the edge. Number of oh, I misread this. I. What is I? Oh, I see. That means that how many nodes are connected through 0? Okay, so then how many nodes are to the left and to the right? I mean, n is 1,000, so I guess that's right. It doesn't seem that bad in theory, but I guess we'll see. Yeah, okay, fine. Yeah, okay, fine. Right. Okay. That's a lot of possible things, right? And then now. Hope this is fast enough in Python. This is mostly right. I have to handle the mod case. Well, okay, maybe it's not right then. Why is that wall? Oh, because it doesn't share any. No, they don't share any edges. Oh, that's why I kind of. Yeah, okay. Because it should not go through stuff that you've seen before. No, that should be fine. Okay, fine. Okay, yeah, fine. Maybe too slow though, but still wrong. Why am I wrong? Do I not know how to code? Yeah, that's probably true. Zero, 5. Where do you get that from? Am I messing something up? Why is there 5 and there's 0? Well, there shouldn't be a 1, so something's really off. Alright. Even more wrong, but that's fine. 1. Oh, because I don't reset this. Okay, fine. Still wrong, but oh, I can't believe I'm debugging this so lonely. This should be pretty straightforward. Node parent, okay. 1 0 2 1. Oh, this isn't 1, this is X, that's why. Alright. I am not a smart man today. A couple of mistakes. No. Ooh, wait, this is wrong. Do we? What am I doing wrong? Why not 2 and 4? Oh, I misread this. It's each one, not. Oh, I am dumb. Okay, so this is actually much easier. I'm dumb, I misread this again. Okay, so what am I doing? No, this is easier, this is easier. Okay, so basically misread this form, but okay, fine. So no, that's not right. Okay, so how do I write it? Okay, so there's all things. Yeah. I don't know, I'm just writing in a weird way. But alright, let's see if it's fast enough. Well, the server isn't fast enough, but and people already got Q4. I misread this one for so long, that's why. Oh man. Okay, well, let's at least look at the other problem. Doesn't even submit. Oh, there we go. I mean, I don't know, maybe I submitted twice, we'll see. Oh, there we go. Alright, focus. I misread that one so hard. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Leave a comment. Stay good, stay healthy to good mental health. I'll see y'all later. I'll see you later and take care. Bye bye.